Let's take a look at a couple of examples of these integration by parts problems. So I will say these take a lot of practice and they're difficult to do at first, but they really do get easier with experience. So the more of these you do, the more you kind of gain this intuitive feel for what should U be and what should DV be, and how will that work out. I want to talk a little bit about using the solutions manual, because I think it's a really helpful thing to look at the worked out problems as you're working on the on your practice assignments. But you have to do it in a disciplined way. And what I mean by that is it's really important that you start the problem on your own, cover over or otherwise hide the solutions manual, work it as much as you can. And usually, at least for me, when I get stuck, it's usually well, what the heck should U and DV be, right? So I might get stuck there. So the disciplined thing to do then is to look at what the solutions manual has for U and DV, and then go, okay, yeah, I got that. Write that down, but don't look at the rest of the problem. And work from there. Work the rest of the problem as far as you can. So work the problem as independently as possible. Look at the answer key just to confirm your answer or to show you the very next step, and then work it the rest of the way you're on your own. I can tell you, if you just are looking at the answer key and reading through the answer and kind of nodding your head, you are not going to learn how to do these. It's just not going to work that way. All right. So, but I would say using the solutions manual is a big help in learning how to do these. Okay. So here's our example. The integral of x cosine of x dx. So I have this product of an algebraic and a trigonometric function in this integrand, all right? And I'm going to use the integral of u dv equals u times v minus the integral of v du. So we have to know that by heart, so it's a good thing to kind of write it down one more time. And I'm going to let u equal x and dv equal the cosine of x. All right. So if I think about my my Lie8 mnemonic, I go logarithmic, inverse, trig, algebraic. Okay, there's no logarithmic, there's no inverse trig. Here's my algebraic. I'm going to let u equal that. All right. Everything else in that should be cosine of x dx. I have to kind of include that dx as part of my dv. All right. So everything else is kind of encompassed in that dv. And notice what we have now. We know the derivative of x is going to be simpler than that. It's just going to be a 1. Right? And the cosine of x dx is very easy to integrate. So it's easy for us to find du and v. So every time we're going to choose a u and a dv, and then we're going to find du and v. So we're going to differentiate the u, and we're going to find the antiderivative of dv. And we get du equals just 1 dx. And when we integrate dv, we get v equals cosine of x, the antiderivative of that is sine of x. All right. So now we can plug those in. We can plug those into our formula here. So I have u dv, x cosine of x dx, equals u times v. So I take my original u, that was x, and my v that I got from finding the antiderivative of dv, that's my uv, minus v du. So v is sine of x, and du is dx. All right, now I can see I have this product. I'm kind of done with that part. This is an easy antiderivative. The antiderivative of negative sine of x is cosine of x. So I end up with x sine of x plus cosine of x. And of course, because this is an indefinite integral, I have my plus c.